do with advanced analysis and quality check. We have several events today, so please feel free to stick around and attend if you have any interest in the other topics. Here you can see a loose agenda of what we're going to cover today, the kinds of things that we're going to discuss, and how to automate that engineering chore related to these items. And this presentation today will be presented by Marco Becerra. He is our Principal Applications Engineer. And without further ado, I will turn it on over to him.
Thank you, Michael, and thank you to everyone that's been participating today. So I will be your presenter, and I'm going to go through these topics and show you the Advanced Analysis and Quality Checker webinar today. Okay, so I'm gonna get started and talk a little bit about 3D Evolution. So 3D Evolution is a tool that allows you to automate the engineering chart. So pretty much anything that you're used to doing manually with your native CAD application, we can do. I'm going to talk a bit about the formats that we support. So when you look at the file open dialog and you click on the drop down, here you can see a bit of the formats that we do. So there are some of these that you might find familiar are DNX, Creo, STEP, STL, um, Autodesk, CATIA, B5, B4, and B6. And we can open up in feature mode, which shows you the individual features of the construction geometry. We can just open the geometry as a BREP, or we can open a lightweight representation. So with that, I'm gonna get started and get two models on screen. And the first topic up ahead is model compare. So we have two different models here. It could be that one is a different revision of the other. So we want to make sure, or we want to document those differences. Or maybe there was a change order and you want to make sure that nothing else was changed. So with the tool that I'm going to show you, it's a very easy to understand and find graphical differences. So one method of opening the files is just dragging them into the graphical window here. So now they're on top of each other. So it's very hard to tell just like that what the differences are. So I'm gonna get into our comparison module and I'm gonna do a straight up geometry compare. We have other modes of comparison. We can also compare the assembly structure alone. We can compare the annotations, just the attributes, or we can do a feature to feature comparison, or for JT, we can compare the monikers. For this demonstration, it's just the geometry comparison. So let me go ahead and run it. So I click on the green check mark and the comparison starts. So what it's doing right now is that it's laying a layer of a mesh in top of each one of these. And then it's comparing each point of that mesh from one side to the other. And the difference in that point will be converted into a color map, which is what you're seeing here on the left side. You're seeing a ruler showing the gradations in color. So the difference goes from 0 at the gray color to the top red color, which means that we have geometry in there that wasn't there before, towards going to the bottom blue, which means there is missing geometry. So it's very easy to see that we have extra geometry here. This part that shows up as orange with red tones, it means that probably something in here changed color. So the easiest way to see exactly how it changed is to just run a section cut through it, and then we turn our review and we're going to be able to see what the changes were. So you can see the before and after. So you can see that this knob was pushed outer a little bit. How much? Well, if we have our mention from picking tool, you can actually click anywhere and it's going to give you the difference. So it's 0.133 millimeters. So that was moved. Also, we see that the diameter was changed a bit as well. And you can also see both at the same time. So you can see side A and side B, and that might make it easier to understand the differences. So we got a multi-viewport display option. So in this case, they're not overlaid. You can see one side on the top and one side on the bottom. and then you can clearly see the name. So this is a sprinkler one, while the bottom one is a sprinkler two. And they are on opposing colors because what's missing on one is extra on the other. That's why you see the reddish tones up above and you get the bluish tones on the bottom. What about differences that might be inside the models? They're probably not visible from the outside. Well, for that, we have the transparency mode. So being able that you see that immediately everything that has a zero difference, that is the gray areas, automatically turn transparent. While the rest of the geometry that might have some difference, it will have a particular color to it, like this here. So this is actually inside. Without the transparency mode, we wouldn't be able to see it. And again, we can do the same trick, run a section cut through it, so we can see exactly what's going on. So here we can see that there's a difference between these walls. We click on it and it's going to give us the number. Or over here, and also we can run the multi-viewport. Usually multi-viewport works better without the section cut. So this is our model comparison tool. We also generate a 3D PDF report and an HTML report. I'm going to show you the report that is built in into 3D Evolution. This is the HTML report. This is actually an external document that you can share with whoever you need to do and to for the purposes of documentation. This is showing us the parts that have the differences, showing you the details when you click on it, and then the parts that are identical. So everything else is identical, and there are no differences between them. But just to get a list of this. And then the configuration information, just so you know what was compared. So no curves were compared. The assembly was compared as a flattened object. So geometry to geometry, not necessarily part to part. So this helps when you don't have the same assembly structure. And the mesh density was medium, and that compare direction was both sides, so A to B and B to A. So in a nutshell, that is our comparison too. So we'll be taking questions. So if you want to raise your hand at this point, you can write your question on the question box, and then Michael, our moderator, will be addressing them. So as you go about that, I'm going to keep going until you tell me to stop. So I'm going to go to the next topic, the collision detection and the minimal distances. So I'm going to use this model. This is the rear axle of a truck. So you see all the elements in there. So well, it looks very nice for a 3D model, but in real life, we want to be able to know if we have any collisions inside, because well, that will be a problem when assembling this into our factory floor. So within our analysis workbench, we have a tool called collision detection. So what it's going to do is that it's going to analyze all of the bodies, all of the parts, and then it's going to see if anybody is occupying the same space as the other one. And then whatever spaces are occupied by two bodies, that means that there is a collision, and then it's going to show clearly. So everything else will be shown in transparent color, while the collisions will be shown as highlighted red areas. So it's very easy to see. And most of our tools use the same system as the one that I have just showed you before, where the differences or the data that you're trying to find is in a color type of map. As this is one of the only tools that shows it in a different manner. So it's very similar interface, except that it's only a yes or no. So is there a collision or is there not a collision? So that's why you don't need a color map. A color map would usually just be a graduation of how much. So we have a similar tool called penetration distance. That one would show you how much one goes into the other.
Hey, Marco.
Yes.
We do have a question. So will you be able to show in the demonstration the comparison between assembly structures?
Yes, I can do that. So let me prepare that while this is running. So I need to get a couple of models for the comparison for showing the structure comparison. So I got that right here.
Why he mentions, and he's pulling up the assembly of it. So a lot of times with the assembly structure, you may want to um, look at the actual instances within the model. So it will show that. But what's also interesting with our model comparison is we said, in some cases, when you have a revision change, you really don't care about model A, you care about model B, which is the second model or the second revision. So you have the capabilities in that process to compare like Class A surface or looking at A to B. And then in addition, there's some other configurations that will show you when he opens up that model comparison. And then lastly, unique to CoreTechnologie, because of the fact that we have the capabilities, when we open up the model, we're opening up from that binary code, we have the ability to open up the fully parametrics. So let's say that you had two models that changed and you're in the manufacturing department of your organization and you're really interested in knowing what specific features change, because guess what? In some cases, the tool is already created and you really need to understand from a feature standpoint what is changed in the model versus just the geometry. And so you have the capabilities of showing that as well. Maybe you can open up another 3D evolution while it's running this process, Marco.
Yes. Yes, I'm getting the models loaded on the screen as we speak in a different 3D evolution window. So you should be able to see it now. Okay, so I have this assembly here. So this is one side. So we have one, two, two instances of the same part, which is part two underscore one and there's two, and then part three. Then we have this other uh, version of the same assembly, but in this case, we don't have instances. These are separate parts. So this is a difference that you might want to find when you're doing an assembly comparison. So I got these two together and ready for comparison in here. So let's go ahead and run a comparison. And this time we're going to be comparing not the geometry, but the structure. So compare assembly structure. Let's go ahead and see what we find. Okay, so we can see that out of all the components, only three are identical. There's one component in the first assembly that is not associated on the other one. And consequently, we had the opposite case on the other one. Let's look at the report. So here is telling you the name of the one that is not associated on the other one. So that means that, well, for one side, we have an extra part, and for the other, the same missing part is extra as well. And here it is the difference, because on both sides we have this part, because that will be the instance one on one side, on the other side will be part one. But on the new assembly, we don't have instance two of part one. We actually have an extra part, which is geometrically speaking is the same geometry as instance 2 or instance 1, but it's actually a separate part, and that's why it's showing up with completely different. You see that it's using the
Mhm.
extreme colors of the chart. So you got a red and you got a completely blue part. So that means that it's completely missing from one side, red, and completely
Mhm.
missing from the other side, blue.
And would it be easy for you to kind of just filter for differences here? I noticed that little check mark up top. So that it's easier, because if you have a large assembly, you only really want to see the differences. And then in addition to this, when you write out the PDF file to this, does it include both the full model and the variances, or and the report? How does that show?
Well, it will include the whole model and the tools to filter out the same that we are doing here. So you could filter it out so you only see the differences. And then
Mhm.
it has a drop, it has a series of filters that you can manipulate the geometry on.
And then also, as you're on this, let's say that I wanted to send this to somebody in a PDF file, and I wanted to put, instead of writing in the email, I just want to write on the actual part itself. Where would I put, comments or notes to that?
Yeah, you can actually add annotations that we show. We have an annotation tool for it over
Mhm.
here. So you can add your notes and measure, you can create measure, and then reference a particular phase, and then add a note based on that.
And then in addition to that, if we know that it's possibly the model or the instance got brought in at the XYZ coordinate, wrong XYZ coordinate, so it's a position of the model, is it easy to change your XYZ coordinates on the instance? Can you create a coordinate system on the actual part itself?
Yes, you can create a coordinate system within this that same workshop that you're creating the annotations. You can create a new coordinate system. And
Mm,
this is something that is often a problem when you have an assembly and you have a bunch of parts, but their parts are within their own origin. Sometimes you might want to have these bodies be in a relative position to the assembly. So like if this had its own coordinate system right at the center, but this is part of the assembly. So there's a way that you can convert this so it will, when put together, even as separate parts, they will be on the same position relative to the assembly. So that's another type of conversion that we do,
mhm.
and it's not a geometry conversion; it's a assembly transfer conversion, and that's actually something that I will be covering. So that helps when you're trying to separate an assembly into individual parts, and you want each part to retain their relative position to the others. Usually
Mhm.
that would not be possible, and you experience get user know this. So when you take an assembly out of its context, it goes back to zero
I see.
in the position system.
So
But we'll
here
be
comes
covering that.
another question when I'm on a roll here, or these guys are on a roll. So one of the questions is, so if you have a lot of changes that are happening, you're dealing with 7 different programs. Is there a way to automatically batch out a new part, or a new, maybe it's just a part within an assembly? Can we implement this like in our, just to go a little further to their question, can they implement this in a batch process and or implement it in a PLM system with ease? If you guys had experience with this?
That is a great question. So and that brings up the topic automation. So everything that you see today can be automated. So automation means that there will be no user interaction. So of course, the ways to initiate these operations without user interaction means that it will be a batch of some sort. So we have 3 different ways of batching out processes. One, we have a web interface and an engine that will take requests via the web. And that doesn't mean that it's the internet. So if you have an internal network, you can run this tool, and it's called our enterprise data manager together with the batch manager. So you can run this tool in a computer inside your network. And that will mean that you have a web interface that will be able to show you, or it will allow you to select any one of these operations and then you can batch out the data. So anyone in the company that has access to the intranet can send jobs to the batch manager, so, and they will be executed in order according to how they were coming in and according to how many licenses you have. So that is one way. The other way is to add this at the end of an existing process. Like you said, if you have a PLM system like Team Center and you have data inside your PLM system, usually you have the ability to create workflows within your Team Center database. And so you can attach our batch processing at the end of your processes. So a very common example is that the translators, that is one keyword built into Team Center. The translators is just a way to say that you can apply external tools to internal data into Team Center. So that's a very big project that we did already for a company, where we attach our translators inside the Team Center tool, and the end user didn't really know what was going on there. Just right click on their data, that would kick off a translator process, and in the end they would just get an email saying, hey, your data is ready and a validation report has been created, so come in and get it. So that happens behind the scene. That happens at the batch level. So your end user really don't even need to know how to use 3D evolution. Of course, that means that you're going to have to predefine your workshops, your workflows. So you're going to need a workflow for whatever you need. If you need a translation to a particular system, or you need just a validation, or you need a simplification, you can create all of these workflows and attach them to processes into your database. So that's another way to automate processes. And then third one that we offer when you don't need that much sophistication, we have a very simple way to automate data. So what we do is that we create a automation tool that will continuously scan a folder, and whatever files you put into that folder will be sent through a particular workflow. So you could have a folder that is called Translate to Step, another that is called Translate to CATIA, another that is called Simplify. So as soon as you drop something into that folder, within 5 seconds, that translator will pick it up, process it, and put it into another folder. So when we have implemented this, we also implemented a validation at the end. So if you do a translation, you want to know that that the translation meets your criteria. And if it's not, it can also be automated so that it is saved to a different folder then, and that folder could be called for review. So you know that the files that are on the for review folder need further attention from you, and the ones that are on the OK folder, for example, or the pass folder, you know that they're just ready to go, and their validation document will be together with them. Just quickly, I'm going to show the web interface that I was talking about. So this is the interface that will connect to our enterprise batch manager. We have a lot of scripts ready-made, but we can also make something specific for you, or you can help you learn how to do them yourself. If you deal with programming, it's not very hard to do. So if you show this to a experienced programmer, they can usually get up and running in a few weeks. So for example, simplification scripts. These are all the simplification scripts. You click on one, then you're given a window that allows you to select for example, your input file, your target folder, and then some of the arguments that that specific script will take. Like you want to remove certain bodies, what will be the voxel size for calculating simplification? Are there any parts that you want to exclude, or any parts you want to remove? You want to create bounding shapes, and so on. So all of these options are also part of the script. They're specified at the top of the script, and then the operations that you need to that you need 3D evolution to run on your parts, they're also specified inside the script.
So can I just ask a question related to that?
Yeah, go ahead.
So do you have the ability to change that script if you wanted to and add some kind of functionality as well?
Absolutely, absolutely. The scripts are text-based. They're not compiled or proprietary. So we'll give you a set of scripts to work with, and then you can look at them and you can combine them, or You can change them. You can reduce functionality they're too much for you, and we can help you do that. And once you learn, you can do it yourself. So they're not in any way restricted or restricting you. What you can do, you can change it. And within our 3D Evolution installation, there is a set of documentation covering the automation and the programming, so you can tweak it to your specific needs.
Okay. Well, we are within the last 10 to 15 minutes, so the floor is open for questions. If you would like to see a point on the agenda displayed in a different way or maybe explained a little further, please let us know also. And yeah, I will leave the floor open.
Okay, and while the questions come in, I will be resuming the collision detection.
So Marco, while this is still running on the collision detection, I want to do kind of an infomercial on our collision detection. Currently, again, he's showing this collision detection on a part and interactively. And so a lot of times there are, if you're working with a team of people, if you're working with a full vehicle, if you're working with a full tractor or a complete aircraft or helicopter as an example, we've used this technology with our DMU inspector with an SQL database that's available for all users around the globe on a global project. And then it's easy to add specific include and exclude. So when he shows you the results of this, you're going to see a lot of items in here like, you know, screws and bolts. Like, we know that's going to collide, right? So that those are items that someone may look at in Europe and they just automatically put it in an exclude list. Well, the nice thing with using that SQL database and using this automated process with the enterprise data manager and the DMU inspector is it will allow you to quickly make those changes. And then for visualization, we provide you a TIFF image, which I think Frank's going to be giving a presentation on the DMU inspector later, if you guys want to come to that. But it will also allow you to update it very quickly. And I believe, I'd have to validate if someone's interested. So in the case of a lot of car companies, they make the large truck, the medium truck, and the small truck. So a lot of the parts are similar, but they may have been scaled, but the include and exclude list might be exactly the same. So to be able to duplicate database comes out to be extremely valuable in time savings as well. And then lastly, this was enhanced with the Volkswagen Group. When I talk about Volkswagen Group, we're talking about the Porsches, the Audis, and the Volkswagen are all implemented this technology together as a team and did a collaboration project to enhance the code to meet those requirements in the aerospace, in the automotive industry. Thank you for that opportunity, Marco, for the
Sure.
infomercial there.
Nice. So I'm gonna go quickly through the rest of the tools that I wanted to show you today. So this is the collision report. You can clearly see where collisions are happening because they are highlighted in red against a transparent background. And there are many switches that you can use while generating this. Again, all of our analysis tools allow you to generate a PDF report, and they also generate a web report that you can share easily and send to anyone, because everyone can open PDF files, and even more people can open the HTML reports. And the other tool that we wanted to cover is the thickness report. So let me run this real quick. So again, this is going to produce an analysis that is based on a color scale, like the other tools. And so we do this because all of our tools will be similar to you. They'll all use the same interface. They all are going to show the information in the same way. So we can calculate this in a couple of ways. We could do ray tracing, or we can do a sphere thickness evaluation. And you can see that the thickness at every point is based on a color. So that means that the thicker part will be white. That thinner part will be going toward the red colors. And here I want to show you our checking tools. So we have several different ways to check the quality on a model. So the basic tool would just check the imprecisions and the free edges. Imprecisions are just units between faces that are bigger than your tolerance. In this case, this is our tolerance. Anything that is bigger than that between the connection of a face would show up as an imprecision. And then the free edges are just parts where the edges are not connected at all, like a hole. For example, you might be missing a face, like here. So we can do a quick check, and that's going to come up 28 and 9, 28 imprecision, 9 free edges. And then we have more advanced ways of analysis that we'll be covering in a further webinar that we'll be doing later today. But just basically, we have an advanced check that we check much more, and we can configure what we can check. So for the advanced check, we will be covering in the topology free edges and continuity. Then we will be covering overlapping elements and self-intersection, curvature radius. But there are much more that we can do, and we can do checks that are based on the VDA standard. So the VDA standard is a quality check that was created by a consortium of automotive companies that came together and saw the need to have a standardized way to compare geometry when dealing with external customers or suppliers. So they needed a way to say this saw is good, this saw is bad. Yeah, but based on what? As measured against what? So they came up with this standard made out of different categories, uh, and we fully support that. These are some of the categories that they put forward. You can see that we have SASIG. I know that both of these are VDA quality checks. And unfortunately, we won't have time to cover all of it today. But I just wanted to quickly touch on these, just so you see we have other categories. And
Yeah,
right now,
I'll get into that in the session at 12 o'clock.
yeah, we'll be talking more specifically about that. So just so you know that it is there. And lastly, the LOTAR validation. So we have David, which is our subject matter expert. Again, on this section, there will be enough time to talk about that. But just LOTAR is the measures taken to ensure that our data can be saved and retained for the longest term. And it can be open not just next year and in 5 years, but also in 10 or 20 years. So a set of recommendations have been put forward by the LOTAR group. So the data that we generate today can be opened up tomorrow. And we'll also be talking more about that in David's presentation coming up next. And with that, I think we are ready. So if any...
Sure, right? I mean, all the things that Marco showed you today is really, in some cases, depending on the department, they want to see it, they want to visualize it. But in some cases, they really just want the results of the file. You know, the designer has already designed the part, so he just wants the results. The guy in the CAE department, again, wants to make sure that it's checked for a tessellated model or that it has the proper thickness before he runs it through CAE analysis. And the manufacturing guy wants to look at the results to maybe from a comparison standpoint. And so if we batch process, if we're seeing consistency with the requests that are coming from the users, no matter what department, that's when we just copy and paste this particular commands in here, and that's how we build that script. And so when he showed you the EDM practices that are used, we can customize again, it was mentioned again that, or if you're not using our EDM that's triggered off, you can do it interactively batch process on the user's desktop. So some of our users are actually doing it through just their own desktop and running something called batch light. So they're not running an enterprise solution, they're just running a local batch process. So I think that's important to mention.